So that monument, they will the short form will call as a BM. Okay. So the standard we will call as a benchmark. Okay, so that is one of a monument in engineering survey. So don't confuse with the boundary mark. Boundary mark, the mark that planted at the each of a corner for the land parcel. Okay, in order to differentiate between your land parcel with your neighbor land parcel. Okay. Okay, before NDCDB, they have a DCDB, Digital Cadastral Database. Okay, in Malay, we'll call it as a PDUK, PDUK, PDUK. Okay, so we'll call it as a PDUK. PDUK. PDUK stand for what? Pangkalan Data Ukur Cadastre. Okay, Pangkalan Data Ukur Cadastre. Okay, DCDB contains all information obtained from cadastral survey jobs related to boundaries of land parcel. Okay, so meaning you need to think back the flow in the field measurement. Okay, once you already finish the field measurement, okay, then you will check your data. You as a surveyor, you will check your data. Okay, and then once you already check your data traverse is achieve first class survey. Okay, what is the first class survey? 1:8,000. Okay, so meaning that data can be used, can be acceptable by the survey department. Then okay, you will apply the previous, you will apply the bodice adjustment. So you will apply the bodice adjustment. Okay, then that data you will send to the survey department. Okay, so once survey department check, okay, and then the survey department will produce the certified plan. Okay, the certified plan, and then the certified plan. Okay, meaning the value of a land parcel that is already measured is a final. Okay, bearing distance, coordinate, area is already in the final. So meaning once it's already final, so that data, okay, will put in the database. Okay, this is what we call as a digital cadastral database. Okay, so dia akan masukkan, okay, bersama dengan lot-lot yang lain yang telah diukur. Okay, the land parcel that is already measured will combine together, okay, with a new land parcel that already measured. The database was created by JUPEM using CALS, or we call as a computer assisted land survey system. So they will have a system. The existing DCDB which cover the entire country to replace the hard copy certified plan, insurance title by register or land office title. So this one you need to think back, okay, about the register and land office title. Okay, so it will relate with the final title. Okay, so this final title under register or land office title. Then the coordinates in the DCDB were obtained from several means and contain varying, unpredictable, and unquantified error. Okay, so on the previous in the DCDB, in the field measurement of cadastral, they will have three type of class. First class survey, second class survey, and third class survey. Okay. So each of that they will have example first class survey 1:8,000. Okay, below than that it will categorize as a second class and the third class survey. Okay, so from different class, so from that you will have a different error, eh? Different error, different in term of displacement. Okay, so how you want to combine, okay, in a one database. Okay, uncertainties of surveyed value are typical, but error are more common in some rural area. Okay, so biasanya kawasan pendalaman, okay, it will have a more error. And then to be able to support a modern cadastral system, an accurate positional record of the cadastral is imperative. The existing DCDB was not designed for this purpose. Okay, in order to support a latest nowadays, and they want to create a multi-purpose cadaster. Okay, by having you have a different class survey, you have a different of error. Okay, how you want to combine in order to combine in one database, and then you want to support with the latest cadastral measurement. So this is not suitable. Okay, so that's why they come out with the NDCDB. Okay, example here, error propagation, second class survey, 1 ratio to the 4,000. Okay, so error propagation on coordinate in digital cadastral database. Okay, so the displacement tolerant 0.05 meter or 50 centimeter. Okay, for the east north and east west and north south. Okay, for the different. But is not more than 50 centimeter? Okay, so it depend on the data, the data, okay, the type of class, and then once you combine together, so what happened to the in the digital data? Okay, so this is the error. Okay, then graphical coordinate error. Okay, graphical coordinate error result in not uniqueness of coordinate of the same boundary point. Example, when you zoom in the digital, you will see they have another line that overlap to the existing line. Okay, when you zoom, you will see this graphical coordinate error. Okay, different type of cadastral coordinate. So they have a rigid coordinate in terms of a homogeneous and systematically adjusted. Okay, how you do for the adjustment. Okay, previous using bodish, now using the uh, survey accurate coordinate method or least square adjustment. Then plotting coordinate for cadastral map plotting purpose. System coordinate when you use the system or software in order to generate the coordinate. Okay, so each of these okay, will produce an error. So example, if you want to use a software, you want to use Excel example, you want to use a Excel that can calculate your data using the bodish adjustment. First, what you can do, you can calculate manually. You calculate manually, and then you check with the Excel. Excel. Example, if you use Excel, you want to make, you can calculate automatically. So you can check whether your answer is correct or not. Okay, same goes if you use another software. Okay, that will make you easy. Okay, in order to calculate the area, to calculate the coordinate, to apply the bodish adjustment. So first, you need to check, you as a surveyor. Okay, so this one, example, the survey value. Okay, so when the survey value, okay, check on the CP. Okay, this one PA. Okay, from the PA image, the distance 90.913. Okay, but when check with the system, okay, 90.855. Okay, so it will have a different about 50 centimeter. Okay, it will have about 50 centimeter. Okay, then on the previous, the datum you will use about the datum we call as a MRT, Malaysian revised triangulation. So in order to apply the cadastral survey, okay, it will refer uh, to the triangulation, okay, geodetic triangulation that created, okay, that established, okay, in the early of the surveying, in Malaysia. So they create a triangulation, okay, for each state. You can see they will have on the each state, but not cover to the all area, and not cover to all area. It's only on the center. But nowadays using the GPS, okay, the GPS, the control already distribute, okay, to all the area, okay, and then it already cover for Peninsula Malaysia. Okay, example here. Then about the adjustment, okay, as I mentioned, Bodish nowadays using the least square. Okay, so Bodish adjustment distribute closing error linearly, but not able to provide a unique coordinate solution. Okay, compared to the least square adjustment technique determine a unique set of coordinate for each boundary mark from a set of observed value, okay, bearing and distance. Okay, so when you use the bodish, okay, when you use the bodish, it will the error will accumulate from one line to the other's line, okay, for your main traverse. But in the least square adjustment, you will see where the line that have more error, so that will have more adjustment to that line, okay, compared to the line that have a small error. Okay, so for today, I think until here, okay. So until here for the lecture class, and then about the about I have one video, okay, that you need to see in order why they nowadays they use the GDM 2000, okay, GDM 2000. Okay, so that video I will put okay, I will give a link, okay, later, and then you can see the video. Okay, for a while. Okay, class, can you see this sample field book?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Okay, I want to explain this one for your fieldwork preparation. Okay, so at least you know. Okay, sorry, I try to check first. Okay. Okay, example here, this field book consists a few station. Okay, until the last station. Okay, is the last station. Okay, the last station, this one. The last station, okay. Okay, the first thing when you go to the site, example, you go to the site and then you required to carry out the field measurement. Okay, so you required to start your survey. Okay, what you can do for a while, um, okay, you write down datum anggaran. Example, you have form like this. Okay, you prepare before you go to the site. You have a form like this. Okay, you write down datum anggaran. Okay, so datum anggaran. Is it this one last semester you have done? Class? You have done using face left, face right.
Yes, sir.
Yes, sir.
Yes, sir.
You have done. Okay. Okay.
Yes.
Okay. But for this semester, I will refresh to all of you for the cadastral environment. Okay, how you want to record the data. Uh, so here I want for each of you. Okay, you write down datum anggaran and datum anggaran, and then the value that you assume. Okay, you put here under average. Okay, under average. Okay, how you want to assume? So you will base on your direction. As I mentioned, example 2 to 1. Okay, 2 to 1 is under first quadrant. Okay, first quadrant, and then you need to think. Okay, is it the direction is about 50 degree or 60 degree? Okay, so then you write down here datum anggaran with 60 degree example. Okay, if nearest to the 90 degrees, maybe you will assume as a datum anggaran 80 degrees. Okay, so you no need to put the degrees, minute and second. Okay, during you record the data. Okay, then what you need to do, you write down from station 2 to 1. Okay, 2 to 1. Example, if you use a wooden pack, you write down here as a PKT, and this one also as a PKT. Okay, then you write down the vertical angle. Okay, for vertical angle, okay, vertical angle, face left. Then this one, slope distance. Okay, slope distance, face left. Okay, then final distance you write under uh, final distance. Okay, horizontal distance you write under final distance. Okay, so the rule for the distance here, it can be horizontal distance or slope distance. Okay, but in this case, for this first line, you will write down as a slope distance because here you record the vertical angle. Okay, so the first line of your measurement, you will write down like this. Okay, if you see the others line, okay, you will see no vertical angle. Okay, unless you continue on the another day. Example, this data is here to continue another day. Okay, no. Okay, if you continue on another day, you will have the daily check. Daily check, as I mentioned before, you will record the vertical angle, slope distance, and horizontal distance. Okay, once you finish the face left for the first line here, then automatically you write down here 2 to 1 with the value that you assume here. Then for the face right, what you need to do under the face right, how you get this data 164 plus. Class, how you
Sir.
get
Yes, sir.
164?
That's right.
Yes, face right, how you get 164?
Minus 180.
Yes, you minus
Minus
180
180.
from the face left because your face left is already more than 180. Okay, so face right you need to minus 180.
It's left.
Okay, then this one directly you write down from here. Then this one you plus minus 180. So this one 2 to 1. Okay, 2 to 1. You want to set the value. Okay, in your total station you will set 3444745. Okay, example you refer the value from this sample. Okay, you will set in your equipment. Then you will turn. Okay, using the face left, you turn to the station number 3. Okay, you turn to the station number 3 and then you write down the value. Example here, the value 3274315. Okay, for the face left. Okay, then once you finish, then you jump directly to here. You write down from 2 to 3. Okay, because for this line, you want to represent the value from station number 2 to 3. Okay, why you not write down 2 to 1? Because 2 to 1 as the reference station, reference line. So you already record on here. Okay, on the above, you already record. Okay, so you write down PKT. Okay, if a station using the wooden pad. Okay, and then here example BKL, batu konkrit lama, because the station 3, okay, the reflector put on top of the boundary mark, one of the boundary mark. Okay, so you write down station number and the description. Then you directly you write down here H. Okay, because we not take the vertical angle. Then you record here horizontal distance. And you record here horizontal distance face left. Okay, so that enough using the face left. Okay, from 2 to 1, 2 to 3. Okay, so once you finish, you will continue the same procedure, the same method. Okay, but now you will use using the face right. Okay, so now example you already finish 2 to 3, then you lose your clamp, then you turn back your total station 2 to 1. Okay, so now what you will do once you turn 2 to 1, class? Okay, you turn 2 to 1. You target back to your reflector. You make sure you already adjust the focusing screw. You want to make sure the object is clear. Then you adjust the eyepiece in order you want to make sure the crosshair is clear. Then you can observe to your reflector. Okay, once you can observe to your reflector, then you need to think, okay, now I am target from station 2 to 1. Okay, you look in your booking. Where is the line 2 to 1? So here, line 2 to 1. Is it your information is already enough? Okay, no. You required to take the face right vertical angle here. Okay, and then face right slope distance here. Okay, I hope student you can take note maybe you sketch in a piece of paper. At least this practice you will do during the field work. Okay, if I mention, okay, now today's class, all of you need to carry out the simple traverse at least 5 station. You can use assume that term. Okay, so you can make sure you set up from one station to another station at least 30 meter. Okay, so saya bagi tahu macam tu. Okay, about the how you want to record the data, it will based on this class. Okay, on this class. Senang sikit because nowadays we need to follow the SOP, and then it will take a time. It will take a time. Example, I go to first group, okay, and then how about the others group? The others group need to wait for me. Okay, with this online session, I hope all of you will prepare, and then once you borrow the equipment, okay, I will go to each group just to see whether you understand or not how you record the data. Okay, if I want to go one by one group, so it will take a time. Okay. Okay. So now your station, total station. Okay. Target to station number one. Then you need to look. You on the first right. You need to record the vertical angle and the slope distance here. Okay. Then 2 to 1. Okay. You already finish. You already finish. Okay, but you not set the value yet. Okay, so you can set the value for the horizontal, okay, horizontal angle at the early stage here, or after you already record the vertical angle and slope distance here. Okay, so the value that you need to set, you will set in the equipment 164.4745. Okay, so that is how you want to record your uh, vertical angle in your face right, or face left. Okay, for now face right, so you use key in using the button 164.4745. Then once finished 2 to 1, you target directly 2 to 3. You target directly 2 to 3. You observe 2 to 3. Then you will get one value for the horizontal angle. Before you record, before you record in this field book, okay. So you can check, you can check. Example here, you can check 157, okay, 337. Is it you minus 180, you will get the 157 plus 337, you minus 180.
Yes, sir.
Okay,
Okay.
okay. Okay, if you already check, okay, all right. So this one, okay, and then this one 42, but this one 43. Is it the different about 1 minute? Okay, is it the different about 1 minute? Okay, because our limit, our tolerance about 20 second. Okay, 20 second. Okay, so example here. Okay, you need to look on the second value. Okay, 15 and 0.5. Okay, so if more than, okay, so I think this one mistake. Okay, if this value is already more than 1 minute, right, class? Betul tak? This one 43, this one 42, this one 15,
Yes, sir.
05. So 1 minit 10. Okay, 1 minit 10.
2 second.
Okay, so but this one, okay, the student write 43. So the mistake here, this one should be 43. Okay, 43. Okay, so now you assume this minute 43, 43. Okay, same value. Okay, and then now 15 and 0.5. Okay, so the difference about 10. 10 second. Okay, so 10 second. Okay, so already achieve within the tolerance. So within the tolerance, so you can proceed. Okay, so proceed record this value. Then you want to write the average here. Okay, you take this value. Okay, and then you plus minus 180 with this value. Then you divide by 2. Okay, kalau untuk cara yang senang, 15 dengan 05, 10 bahagi 2, 5 kan. So maksudnya dekat sini 15 ni you bahagi you tolak 5 je. So dia akan jadi 10 second. Okay. So 3, 3, 7, 4, 3, 10. So this is you put under average. Okay. So this one you abaikan dulu. So this one correction. Okay. This one pun you abaikan dulu. Bila ada correction baru kita akan dapat final bearing. Okay. Once you already calculate the average, then proceed here. Okay, so this one distance, this one horizontal distance or slope distance class? Horizontal distance. Okay, horizontal distance. As I mentioned, only for the first line here. And because you take the vertical angle, then this one should be slope distance. Okay. So in this case, this one you not take the vertical angle. Okay, because in the cadastral, as I mentioned, we only want about the 2D data. We only want about the position, about the coordinate. Okay, no need about the elevation. So we don't want about the elevation data. So no need to record the vertical angle here. Okay, but in the engineering, if you record the data, so this one you need to write down the vertical angle. Okay, and this one once you record vertical angle, this one automatic slope distance. Okay, in the cadastral, this one you write down as a for the H horizontal. So meaning this one you take the horizontal distance. Okay, this one face left, this one face right. You average these two value, you get the final distance. Okay, so that is the practice that you need to do in the cadastral. Okay, same goes to the others line. Example, if the others line, okay, refer to the same line as above, so it will write as a seperti di atas. Okay, seperti di atas. Then you want to observe 2 to 4 again, 2 to 1. You target 2 to 1, then you set this value 3, 4, 4, 4, 7, 4, 5. Then you turn 2 to 4, then you record this value. Then you write down 2, description, 4, and then description. Then you put H here, then you record the horizontal distance, face left. Okay. Then, okay, you turn to the face right, 2 to 1, set value 1644745. Okay, loose clamp, target 2 to 4, you record this value. Again, check within 20 seconds or not, 18303, okay, 0202, okay, 3550, okay, 3550, so 15 seconds, okay, accept. So automatic calculate the average. Then now record the horizontal distance, face right, average the value, write down here. Okay, so that what practice that you can apply. Okay, during the if I want you all to record the data in the field book. Okay, any question you want to ask? This one correction, this one M correction. Example, okay, after you have done the measurement, okay, during the fieldwork, you have a line that you carry out the solar observation. Okay, so from that solar observation, you will have the correction. So that correction we will write down as a M correction. Okay. Okay, if you see the C correction here, C correction means you apply for the main traverse. Okay, main traverse mean the loop, closed traverse that have a loop. Okay, they will have a C correction. Okay, about the correction, Later we will discuss, but for now I want you all to focus how you want to record the data. Okay, because during 2 hours, okay, if I want to explain about how you want to record the data, okay, it will take a time, and then you borrow the equipment, and then suddenly you cannot do the field work yet. Okay, maybe you only can finish about one station only. Okay, so how you want to complete your practical task. Okay, others question? Okay, if you don't,
Yes, sir.
ah, okay, if you don't have any question, I think that's all for today.